Alright? And remember with parentheses, it's always going to be the opposite. The opposite of plus 5 is negative 5. So we're going to take each of those values and subtract 5. That gives us our appropriate x's, which is negative 4 2/3, negative 4, and negative 2. Negative 4 2/3, negative 4, and negative 2.
So this subtracting the
See my base?
Yeah.
What's the base of my log? 3. So the mother function x's would be the 3. And the log 3 of 3 is 1. 1, because the log of 1 is always 0, and then 1/3. That gives you the negative 1. So it's always 1 over the base, 1 and the base. Make sense? Look at my base. My 3x's are 1 over the base, 1 and the base. Because when you plug those in, so if I do the log 3 of 1/3, it always gives me negative. If I do the log 3 of 1, that gives me 0. And if I do the log 3 of the number, the log of a number cancels each other out. I'm bringing back to 1. Okay? Whatever the base, it's always whatever the base is. The base. Alright? Why? Because when I now plug in negative 4 2/3, negative 4 2/3 plus 5 is 1/3. Log 3 of 1/3 is negative 1. Negative 1 times 2 is negative 2. Negative 2 minus 1 is negative 3. When I plug in the negative 4 plus 5 is 1. The log of 1 is 0. 0 times anything is 0. 0 minus 1 is negative 1. And then when I plug in the negative 2 plus 5 is 3. The log 3 of 3 is 1. 1 times 2 is 2. 2 minus 1 is 1. If you do it correctly, your y should go up the coefficient of the entire expression. Alright? Negative 4 2/3, negative 3. About there. Negative 4, negative 1, about there. Negative 2, positive 1, about there. With logs, I would definitely draw your asymptote. Your asymptote is the opposite of the parentheses. What's the opposite of positive 5? Negative 5. And there's my graph. Domain x is greater than the value of the asymptote. Range for that is all real numbers. Could be the x is greater than 5 or what? Negative 5. Sorry, I'm in the wrong part. Alright? All good? Better? Okay. For the second one, next one over, what's my base? 4. So I'm going to go 1/4, 1 and 4, and then do the opposite of the parentheses. What's the opposite of negative 7? Add 7. Again, it can be going on paper or in your head. Either way. That gives me 7 1/4, 8 and 11 for my x's. Good? Good? Alright? Because when I plug it in, this becomes 1/4, that becomes negative 1. Half of negative 1 is negative 1/2 plus 2, 1.5. When I plug in 8, 8 minus 7 is 1. Alright, log of 1 is 0. 0 times anything is 0. 0 plus 2 is 2. What's up?
Can you, so if I want the y's repeat, can you plug the log like into the calculator, or is it just
The
like
problem is you're not, it doesn't have, not really, because you don't have the base. That's the idea behind this. That's why we're finding particular x's.
So I would have to know like
This is what you need to know.
Certain, like, log
This
values.
is what you need to know. Log base n of 1 over n is negative 1. Does that make sense? So whatever the base is, the log of 1 over that base is negative 1.
Okay.
Log base n of 1 is always 0. Make sense? And then the log base n of n is positive 1. That's what you need to be able to do. Because what you do, now what's going to happen is you can use the calculator, I'm fine with it, but picking these x's shows you understand that you can do it without a calculator. Does that make sense? Because these are what it's giving us rational values. Because everything else is kind of an irrational value and estimate. If I plug in 11, 11 minus 7 is 4. Log 4, 4 is 1. Half of 1 is 1/2. Plus 2 is 2.5. Again, each time it's going up the half. So 7 1/4. 1.5. 8, 2. 11, which is out here. 2.5, which is up there. Again, the opposite of the negative 7 is the plus 7. So there's your asymptote.
So with these ones, the asymptote is always going to be
Vertical. No. Because you got to remember, this is the inverse of exponential. So everything we did for exponential is going to be the opposite.
And the asymptote is the one inside parentheses. It's not the one that's outside. Like,
Right.
anymore.
Right. Okay. There's no base, so we assume it's a common logarithm. So I start with 1 over 10, 1 and 10, and then I subtract 1 from each of those, which would give me 9/10, 0, and 9.
What did you subtract? -1.
I took the plus 1 to the opposite, and then I did that to each of those values. When I plug in 9/10 plus 1 is 1/10, that becomes the negative 1, but the negative on the outside makes it 1. 1 plus 3 is 4. When I plug in the 0, 0 plus 1 is 1. The log of 1 is 0. Negative plays no part. 0 plus 3, 3. When I plug in the 9, 9 plus 1 is 10. Log of 10 is 1. Negative makes it negative 1. Negative 1 plus 3 is positive 2. Yes, ma'am.
I know, like the log rules and stuff, but like how do you know that log of 10 is going to equal 1? That's what I'm.
So when it has no base, it's the common logarithm. It's got a base of 10. So this is the same as negative log 10 of x plus 1 plus 3. So it's the same as the other ones, whatever this is. So when I plug in the 10, the log 10 of 10 is 1. So the only difference between this and that is the base is 10. So see how the one the next to it has a base of 3?
Yeah.
This one just has a base of 10. 9/10, 4. 0, 3. What did I do? No. This should be, hold on, negative 9/10. Sorry. Negative 9/10, 4. 0, 3. 9, 2. Opposite of positive 1 is negative 1. That's your asymptote. That's why I knew I messed up. Your domain x is greater than 1. Your range is all real numbers. That's the idea when you have multiple things going on. And when we say multiple things, you have a negative in front of the x and then a plus 7. So either in your head or on paper, you then have to take that expression and set it equal to 1 over the base, 1, and then the base. Alright? Negative x plus 7 is equal to 1, that makes x 6. Negative x plus 7 is equal to 3, that makes x 4. The struggle for some people working with fractions is this one, but you end up with 6 2/3. When you subtract the 7, you get negative 6 2/3. Divide by the negative 1 turns it into a positive. Good? So either in your head or on paper, you're doing that. Because you have fun.
Oh, okay.
See what I mean? That's what we mean by multiple things going on. Alright? So when I plug those in, 6 2/3 to the negative is negative 6 2/3, plus 7 is 1/3, the log 3 of 1/3 is negative 1. When I plug in the 6, I got 1, the log of 1 is 0. When I plug in the 4, I got 3, the log 3 of 3 is 1. 6 2/3, negative 1, 6 0, 4 1. Negative x plus 7 equals 0 is your asymptote. Negative x equals negative 7. X equals 7 becomes your asymptote. Here's your graph. Your domain, x is less than 7, and your range is all real numbers. Good. Everybody good with that? Measure resulting values. All right. Now, because there are no parentheses, my asymptote is the y-axis. And it's kind of hard to see, but that's generally the shape of your graph. It's just a curve. Alright? Don't worry about this one, won't show up again. Don't worry about this one, won't show up again. Alright? So we'll look at this one, negative log 5 of negative x plus 1 minus 3. That's the extent of when you have to solve for it. So negative x plus 1 equals 1 over 5. Negative x plus 1 equals 1. Negative x plus 1 equals 5. That's the extent of the multi-steps involved inside the parentheses. And then you solve each one. If you're going to struggle with that, I would suggest you do the second two first, because they're easier to do usually. So in other words, that becomes 0. This becomes negative 4. And then just work on this one. Feel free to use decimals. 1/5 minus 1. It's negative 4/5, but the negative makes it 4/5. When I plug in the 4/5, I'll end up with 1/5. Log 5 of 1/5 is negative 1. Negative of the negative turns into a positive. 1 minus 3 is negative 2. When I plug in the 0, I get 1. The log of 1 is 0. 0 minus 3 is negative 3. When I plug in the negative 4, I get 4. 4 plus 1 is 5. Log 5 of 5 is 1. Negative makes it negative 1. Negative 1 minus 3 is negative 4. The y's are going down 1 each time, which is consistent with what's going on there. Alright, to get my asymptote, negative x plus 1 is equal to 0. X equals negative 1 when I solve it. Sorry, x is just 1 when I solve it. So that's there. I then plot my points. 4/5, negative 2 is here. 0, negative 3 is there. Negative 4 is here. That gives me the general structure of my curve. I'm good to go. Alright. Everybody get a good idea now? Alright. If you haven't submitted already, make sure you submit that. If you haven't submitted already, make sure you